Then let's substitute the safe functions. So n1 is 1 minus xi 1 minus eta divided by 4, and the coordinate x1 is say minus 1, plus n2 is 1 plus xi 1 minus eta divided by 4, and x2 is 1, plus n3 is 1 plus xi 1 plus eta divided by 4, and the coordinate x3 is 1, plus n4 1 minus xi 1 plus eta divided by 4 into x4 is minus 1. x4 is minus 1. Now similarly, let's find out dx. So dx will be equal to, now this dx is, this is minus, so, or dx by dxi. Let's calculate dx by dxi. So this is equal to 1 minus eta divided by 4, this is negative. Then this is plus 1 minus eta divided by 4. This is plus 1 plus eta divided by 4, and this is minus 1 plus eta divided by 4. So now we can take this 4 as common. So this is 1 by 4 minus 1 plus eta, then plus 1 minus eta, plus 1 plus eta, minus 1 minus eta. So this gives us the value, say, unit. Similarly, dy is equal to, now 1 minus xi 1 minus eta divided by 4, and y1 is minus 1, plus 1 plus xi 1 minus eta divided by 4, y2 is again minus 1, plus 1 plus xi 1 plus eta divided by 4 into 1, plus 1 minus xi 1 plus eta divided by 4 into 1. So here also we can find out dy by dxi, dy by dxi, and finally we will get here a Jacobian matrix. But here, while calculating dy by dxi, again, see, this is minus, so you will get, so let's take 1 by 4 outside, so in bracket. So this is minus 1, minus minus plus eta. Sorry, dy by deta. dy by deta we have to calculate. So this is 1 minus 1 plus xi. Similarly here minus 1 minus xi. Then here it is plus 1 plus xi, and again plus 1 minus xi, and you will get 1. So Jacobian matrix here or constant we will get unit. And the next step is to find out the strain displacement relations, or we have to calculate the strains. So how to find out the strain displacement relations? That is, we have to use diaba u by diaba x. So let's find out strains. This is our generally second step. So first is we have to assume the displacement function, and second step is to calculate strains or strain displacement relations. So dabba u by dabba x. This is equal to dabba u by dabba xi and dabba xi by dabba x. So this we can do. Next, dabba v by dabba y will be equal to dabba v by dabba eta into dabba eta by dabba y. And gamma xy is equal to dabba u by dabba eta and dabba eta by dabba y plus dabba v by dabba xi by dabba x. So now with this derivations, with these differentiations, we can calculate the strain displacement relations. And finally, in symbolic form, we know that this strain is equal to the strain matrix B into the displacements. So once we get the matrix, strain matrix B, the next is stress strain relationships, or we can simply say the stresses. The stresses sigma is equal to the matrix D into strain. That is matrix D into strain is B into delta. And then fourth step is by using principle of virtual work done. That is, virtual work done must be equal to total strain energy stored. Must be equal to total strain energy stored. That is, virtual work done is virtual displacement transpose into corresponding forces into triple integration. So this is B transpose D into B. Actually, this should be by using stresses and strains. Total strain energy stored is the strain due to virtual displacements and stress into dx, dy and dz. So this is now equal to that displacement transpose into force equal to triple integration. Now strains, we will substitute for strains. This is delta virtual transpose, then matrix B transpose, then similarly stresses, this is D, B and delta into dx, dy and dz. So this delta virtual displacement vector gets cancelled, and also we know that the integration dz is nothing but thickness of the element. So now we can write down this as F is equal to, so this is minus d by 2 to plus d by 2 minus, sorry, this is minus a2 plus a integration minus b2 plus b. So B transpose D B into thickness T into dx dy into the delta, that displacement